My name. I'm Stephen Foskett, your host for Storage Field Day here in San Francisco. We are wrapping up this very compact edition of Storage Field Day with a delegate roundtable discussion. We're going to react to the presentations. We're going to think about the technologies. We're going to talk about the implications of what we heard. And we're going to predict the future of storage a little bit. So joining me for this roundtable discussion are the Field Day delegates. It gives them a chance to give their feedback and have a productive conversation. So Storage Field Day 25. Was this the old school storage? Was this new? What do we got here?
Block in this discussion. I mean, it was just it brought a smile to my lips to see that we're still talking about block storage. Block storage is still important. Performance is still important, and sophisticated features for block storage is still important. I mean, the EBS thing was very good. I thought the storage pool stuff was pretty hot. Cybersense was cool. I think all the stuff with respect to ransomware and what they're doing to try to detect it was pretty damn interesting. And even the global data platform was okay, although it wasn't necessarily block.
I was going to say that's unstructured.
That's the only one that wasn't block. So I mean, it's old style storage, right?
Well, was that because of the industry, or was that just because a coincidence of which companies we had presenting?
I think it's a decent amount of the industry. I mean, no matter what we all do and what everything comes, like old school database servers still exist, thank God, because otherwise I don't have a job. And the data has to be stored somewhere, and that somewhere is block. And that's how we present the storage to old school servers, and they run the infrastructure.
And it can't be stored in software.
Yeah, I also believe it is mostly because of the industry, and also Ray's point of yesterday, like where does application live, there is the data. Similarly, what application does or what type of applications demand is, that's how we store it. Like with containers and all this new type of applications which are cloud native, they have this volume requirement. All stateful applications need volumes, and the best way to provide a volume is on block if it is performance sensitive application. Most of the databases are very performance sensitive, so that makes sense to put it on block. That's why we are seeing this block storage again reviving as a common industry trend. I know a couple of vendors also who are working on new product lines specifically for distributed block storage. That also solves a use case for distributed SQL databases which are coming into market. A lot of startups working in that area, and this solves that use case well. Storing it on a file reduces the performance, but then it has its own benefits. But yeah, that's the trend.
I was reflecting a bit on what Ron was saying here about block storage and overall. I mean, some more kind of general thoughts. It's true that I was working recently, and we're in the process of getting that published soon on a report on object storage, right? And you do have some vendors, and we had a discussion before yesterday that claim that object storage is becoming primary storage because of new applications that use and so on. I still think, however, that there are still a lot of use cases for block storage. We've seen that with companies like Storepool that we heard today. They have a very compelling solution. They have a performance, good scaled architecture. We still do see some good or some great rather architectural value there. But the thing still remains for me, I mean, regardless of the technical merits of each solution, these things are becoming more and more commoditized, right? So if you look at it from the business perspective, is the architecture that important today? I mean, it's not like we are in an age where we are still kind of trying to optimize. I mean, things are more or less similar. We heard Andy before say that the architecture that the Storepool guys have kind of is reminiscent of what SolidFire had like 8 years ago, right? So when I'm looking at storage solutions nowadays, I'm more trying to look at the adjacent capabilities that they offer. Because in the end, these are the capabilities that help organizations drive, better value out of the solution, whether it's data classification, whether it's ransomware protection, and so on. So that's kind of my take more on that.
No, I was going to say that one of the things I think we see, we were talking about IBM and AWS and with its unstructured, structured block. At the end of the day, right, everything ends up being a rudimentary block storage solution. Everything. I don't care whether it's unstructured, object, it doesn't matter. Everything at some point becomes block. So I think what we are focusing on here are more storage solutions, right? These are things that how data is presented to customers in different protocols and ways to do it. Even there are some vendors that I've worked with for years that have a block solution. It sits on a file solution that goes back to a block solution. It's really about, I think we focus on two different things. In past storage field days, we've talked to, like Solidigm and the physical storage media that's out there. And that's a very interesting topic, right? That's storage. All the things we've discussed, whether is a protocol and a presentation layer of data to these customers. And then some of these other vendors like Cybersense go and provide other solutions on top of those solutions to get more value out of it. I think a lot of the presentations we saw of all the vendors was more focused on the value of the solutions that they do. Because at the end of the day, it is commoditized, Mac. You're absolutely right. I mean, the storage, the actual storage part of this, when it gets real, right, physically, is commoditized. And although there's a lot of interesting stuff going on there, we didn't really discuss a lot of that. What we're discussing more of is a data presentation to customers, whether that's block or object or unstructured at this point. I don't know if that's becoming more or less interesting. It's because that's also becoming commoditized.
Well, and yeah, I was going to kind of mention some of the same things. The EBS presentation it's like this was interesting things, except they're just talking about the same data services that storage vendors have been providing forever. It's like, yes, we have the storage services that you're familiar with. Here's how we present them. Here's how we lay them out. But they're again just the data services you expect when you have storage. The IBM presentation was, they have global representation of all these things and are offering them in multi-protocol formats, but at the same time, at the end of the day, it is presenting storage services through multiple protocols the same way that things have been going for a while. The data global
data platform.
Global data platform. It is a larger, more global way of looking at it. But as I said, when that presentation was being given, what they've laid out is the access to caching and the management layer are the exact same thing that you have in big storage systems forever. Actually, the one vendor that I thought had the most, new topics was the index engines, the Cybersense. It's all the scary new ransomware attacks that are out there, and when he just started laying those out, it's like, wow, okay, there's some people who are using their head the wrong way.
Yeah, I will definitely agree with you that on that note. I mean, I think that the as y'all were saying, the storage adjacent things, like Max said, the building on top of storage. I mean, that's as we said at the beginning roundtable for this event. That seems to be the direction the industry is headed. But one thing I will say, though, we don't want to damn people with faint praise. And I think it is damning with faint praise to say all this thing does is offer a complete, reliable, high availability, high performance enterprise storage solution. All it does, are you kidding? That's really hard to do. And it's pretty cool that we have a lot of solutions that are, all the way from hardware to scale out, to software, to block, to file that do all these things.
Well, if you go back to what we talked about in the initial roundtable, one of the things we talked about was just the consumption model of the storage. And one of the things that the global data platform demonstrated was that they are thinking about presenting storage in more like a cloud-like structure. They're talking about presenting things as object, which is the exact thing we talked about at the beginning roundtable.
I think one very interesting point that could also be brought to the table, because we know that storage is there with lot of hardware in it, lot of software running on top of it, failures can happen. We touched that topic in terms of redundancy, but what about real use cases wherein failure is happening and what the company's product is doing to fix it, to figure it out? We all know that corruption bugs are very common in field. How those are getting mitigated by, so no product is perfect, that is for sure, but when we run into issues, what's the mitigation plan? Those points could also be factored in, which will bring another perspective to the table.
Yeah, no, these are all great points. I had a little bit different take on it. I went to bed last night thinking about this. I'm seeing an amplification of this fork in how storage and storage adjacent companies are marketing. You've got one path, which is we can do storage better. It's bigger, it's faster, multi-protocol, block, object, whatever. And then we've got a whole different fork, like, yeah, we do storage, but we do all these other things. Both of them are presenting the value proposition in the direction that they're traveling in, where we do all these different protocols, we do all these different things. Here's our value. We're better than everybody else because we do more. And there's another one, we're really good block storage, and that's our value prop. And it's an interesting sort of rift like this, watching the companies go in a couple different directions, and they're all the right direction for them. It's neat watching that shift.
Which is interesting with that as well, if I can just jump into that quickly, is that it also kind of dictates what you do as a customer, the choices that you make, because you may need to solve one or two problems and you want them to be solved in the best way possible. In other cases, you need to solve a ton of different problems and you want to solve them perhaps well enough or just well enough. And I'm not saying that in the sense that the vendor which is selling those solutions or which is able to cover everything across a larger scope, is doing it badly, but you will have to do some trade-offs, right? So let's imagine that you want to go for one vendor's ecosystem, then you will get eventually some better efficiencies, better management, you will simplify in a way your operations, but you may have to do some trade-offs with performance on one thing, with scalability on another solution. So the fundamental problem that an architect, an organization needs to look into the solution, evaluate, is not gone away because we have those many different solutions nowadays.
The thing I found most compelling was the index engines, Cybersense, because I was just reading in my feed, I had a little interesting blip that a Russian hacking gang called Clop, I guess like a horse's foot coming down,
it's actually two empty halves of coconuts and you're banging them together.
Yes.
I see. Thank you for the Python reference. But apparently they used the Go Anywhere tool to steal stuff from 130 organizations. And the line that grabbed my attention was, it's not clear if Clop yet knows what data it has stolen. Think about that. That's really frightening. And I thought Cybersense, these other vendors that we had were like, oh yeah, we know whatever is going on. But Cybersense was the only product that really said, this is a serious problem and we've got a solution to it, and it'll run on top of just about anything that we saw in the last few days. To me, that was the most compelling.
Yeah, I would imagine the breaches like this one are literally just they're going to suck up everything they can like a vacuum. They'll figure it from the attacker's perspective. Yeah. Suck it all up now, and I'll figure it all out later. So what I've actually got, because I don't have time to care, because my victim is going to shut the breach down at some point, and I want to take as much as I can.
Exactly.
And this way they can do that, and they just don't care what they get. Hopefully they get something good.
Yeah.
That they can commoditize.
It was funny because they actually said that I think Macy's they stole, or Saks Fifth Avenue they stole data from, but Saks is saying, no, it's just our fake customer data. And I'm like, yeah, right.
Sure it is.
Sure it is. So to me, I think that's going to be part of any further storage field day discussion.
I wonder if things like the index engines type of solution is going to become future table stakes for storage vendors to start including by default as part of their offerings, since they're providing storage solutions, as we were talking about before, right? If you're doing unstructured data or even structured data and you're serving this stuff out, will storage vendors now have to really start to embed some of this intelligence and the scanning capabilities, heuristics, like index engines, perhaps, even licensing their technology for such an event as part of their offerings, like Dell is doing for their cyber resiliency services today. And they have similar stuff for some of their unstructured stuff, unstructured production storage, for instance. But it's not index engines; it's somebody else. But what you wonder is that as we start to get beyond just storage is block protocols, iSCSI, unstructured, whether the SMB, NFS, and object, whether or not that it's going to become something like, okay, well, we have these protocols, but then on top of that, we have security layers to make sure that the integrity of that data is going to be protected from all these sorts of ransomware attacks, since it's so prolific and ubiquitous out there.
Well, I would not be surprised if storage vendors do start adding into this, but I think if history is any guide, what we're going to see is a bunch of halfway, kind of also barely minimum viable product kind of features. Because if you don't know what you're doing with data analysis, data management, you're not going to actually do a good job of it. And I think we've seen a lot of this from the storage industry. I mean, you look at all the storage companies out there saying, yeah, we've got ransomware covered. Well, if that was true, I think we might notice it. Yeah, I think that a lot of people, there's a lot of architecture, a lot of branding, a lot of redoing things that they already do. So yeah, I think you need to be good at it in order to do a good job of it.
Perhaps that's why I think index engines licensing themselves to other vendors is the way to go for them, but also perhaps better for the storage vendors and us.
Yeah.
Well, one of the things I think is going to probably stop it from being included with the storage products is it takes a lot of CPU. I mean, those guys were talking about, their customers are rolling out 15, 20, 30 servers that are processing everything on the array. That's a lot of CPU to just be included with, your standard storage platform.
But that's give it away.
Yeah, they're not going to give that away. So they're either going to charge you an arm and a leg for it, or just leave it to a third-party company to provide that service.
That's always been the cost with such added security features. Whenever we add security, we consume a lot of resources. Having said this, optimizations can still be possible, and they can reduce their footprint of such resource utilization, which I think it's like an ongoing activity for them also. But technology-wise, I think it was very cool.
Oh, most definitely.
Yeah.
Completely agree. It's very cool tech.
Yeah. To your point, though, the first 3 large DR projects I did that were storage related weren't driven by the IT infrastructure group or the storage folks. It was the CISO that forced them into doing DR because they were out of compliance. In one case, it was a bank. It was OCC compliance.
Wow.
So in this particular case, it's the same idea. It's like, yeah, is it going to cost more? Yeah. But the CISO is going to be like, you're going to do this. Audit committees are going to be like, you're going to do this. And because if you don't, you're not getting your budget for your other stuff.
Right.
So, I think it'll happen.
So yeah, I definitely think that was a compelling story, compelling product. Another thing that occurs to me is I think if you asked most people about cloud storage, right? What would they say? Cloud storage is object. It is S3, etc. We didn't hear about that. I mean, we heard about that at the last storage field day from Amazon, but this time they were all block and data protection. That's cloud storage too, isn't it?
Yeah.
Of course, the protected ones were object, the snapshots. So,
and the backup.
Yeah.
I mean, the instances in the cloud, they got to run somewhere. And they were talking about some pretty powerful capabilities of data movement, data preservation, cloning, hierarchical storage management, et cetera, with these various blocks in the cloud. I think a lot of us, a lot of people, I don't want to blame you, but a lot of people out there, if they know about EBS, they probably think that EBS is just that sort of stepchild, nothing storage that you occasionally use to boot up your instance.
Except that every VM in AWS has it.
Yep. I don't think they think about all the ways that it can be used and all the capabilities it has.
It's funny if you almost imagine there's like a really big old compellent running in every AZ with all the tiered storage capabilities it used to have, and they're able to do it. But I really thought that their SRD protocol
that was
theirs,
cool.
but and it's a function of their Nitro card and what they can do on their network is it's a game changer for that kind of reliability and performance on storage. It really it shows you that they are thinking correctly on how to do this at scale and how they are able to do things that just others can't do. I mean, they just don't have the technology or the investment.
And also the optimized.
It takes time and money to do this, and thankfully, Amazon has lots and lots of money, and money makes time shorter.
But as they realized recently,
You don't have all the money. You
don't have all the money for all the time.
Right.
I want to come back to this ransomware things. What just came in my mind in former days when a customer decided to buy some storage box, he could have some proof of concept, could maybe build this thing up and run some tests on it, run some performance tests, and knows what to expect, or he knows, okay, this is exactly the box I want to have. Now with this ransomware things, how would you test it in some proof of concept? Will you put it there and say, hello, here I am, please throw some ransomware to me? And the other thing is, to decide if the technology is good enough for me, I might have to need some knowledge about it and need to know how things work so I can decide, okay, this is good for me or not good for me.
Honestly, Wolfgang, with that, this technology now is in place at enough large and credible clients that there's a lot of people you could talk to that are running stuff in production that would be very happy to explain how it works for them. I would agree that if they were like some startup that was like showing you the cool things that they could do, you'd have an absolutely valid concern there. It's like, how do I do a POC? Now they're saying they come in, they bring in, they'll go find stuff that, they'll find stuff that you didn't know about in many cases. And I buy that too. But, in that kind of a world where trust is low, you do have to get some reference clients that are like you. And at this point, there's so many clients that you're probably going to find one that looks a little like you as a business. So that's how I would feel better about it.
Yeah. I mean, and you could POC it. I mean, you could build up basically an isolated network, throw a bunch of garbage data on it that you just download. I mean, there's stuff with Stack Overflow. So you could pull that down and then basically infect it with ransomware and see what the software does.
As a new startup, a consulting service.
Right.
Yeah, ransomware as a service. No, not that.
Yeah, the on-purpose version of ransomware as a service.
The number of storage startups are shrinking because I think a lot of the development is going to the cloud.
Yeah.
And I think if there's a startup now that has some revolutionary technology, we might not even see them before they are acquired by some of the cloud vendors.
What kind of revolutionary features do you think an imaginary new storage company could come up and invent? Like what don't we have that
CXL, computational storage, and an array?
Well, computational storage is a thing. It's there, but what's the need? Where's the use case? Where's the killer app?
Actually, I think a perfect example of this would be Fungible, who we talked to last year, or talked about last year, who were creating their own DPU and got scarfed up by Azure. It was one of those things where they never even went to market with theirs and were acquired by hyperscaler.
Yeah, for quite a low price, I understand.
And that was actually a hardware startup.
Right.
I think if we're thinking in terms of software startups, I think if you actually have a compelling storage software service or product that you're coming up with, those are going to get scarfed up even faster, largely because they probably don't cost as much to buy.
Oh, I agree with that.
Yeah.
I think in terms of
or to build, yes.
I think in terms of features and capabilities, there would not be any difference. But how you are doing it, what kind of, so it's more about same features but better efficiency. I think efficiency matters a lot, considering that commodity hardware is cheap, but commodity hardware at scale is also costly. So doing things right with new things coming in, like even for computational storage or the Excel in picture, with all these things coming in, and what is happening? We are just trying to raise that performance bar up and up and up. We are not satisfied with what performance we can get out of the box right now. Why? Because there are applications which are so performance hungry, they just keep on needing more performance. How to do it?
Yeah, that's a real good point, because think about it. I mean, if you said, oh man, this is a petabyte scale storage array, you'll never need more storage than that.
Exactly.
Said nobody ever. You'll never need more performance than this. This is all the performance you could ever use.
Yeah, I want to jump on that because there are a few interesting things in what Rohan was saying before. First of all, we are talking about performance, but we're not talking about energy efficiency, which is maybe not a challenge in the US, but is certainly a challenge for us in Europe. So when you look at what you get with a community-based architecture versus an optimized architecture, and by optimized architecture, I'm looking at a kind of a design which takes in consideration, the density, and talking about storage, density of the storage, the overall efficiency. So I'm talking about performance delivered versus, how many watts are consumed. You could have a solution which is extremely fast and extremely delivering high performance, but which can be terribly inefficient from that perspective, right? So that's something to take into account. So there is a first aspect. The other aspect is that we have that thing which is going on. Some people believe in it, some do not, which is called climate change. I think that we are seeing some major changes ahead. So that's also impacting the way we're going to do computing in the future. But now you can throw whatever you want at the CPU because you don't care if you're optimizing your application or not to be efficient, right? You develop in whatever language you have. If the language is not efficient, if your code is not optimized, well, who cares? As long as you can throw some fast CPUs to that. But will we eventually get to a point where we will get into a more of a kind of a scarcity economy where we need to consider better what we do, optimize and so on? Then maybe these will be much more relevant, the overall efficiency of the solution. So performance versus what it consumes versus the outcomes delivered. I mean, that's a bit, let's say, an utopian view perhaps for now, but that's something that we may need to take into consideration in the next few years or in the next couple of decades. I don't know.
That's really important, and I don't think that we actually are looking at that enough. One of the trends that we've actually seen over the past, 4 or 5 decades are that higher and higher levels languages are being used to put together applications and utilities that are less and less CPU efficient. More overhead in the programming language, and they're sloppier constructs in the programming language, and they aren't nearly as CPU as efficient as they could be or need to be because CPU is so cheap. And there's, I do think that there's a handful of companies that actually spend an awful lot of effort to optimize their software to take advantage of the CPU that's available to them. And storage should really be one of the industries that pays close attention to this, because the idea that you need to run 100 CPUs to serve several terabytes of data is terribly inefficient. And unfortunately, that's the way an awful lot of things operate right now. What I was kind of impressed with the guys today, Storpool, thank you, was that they actually were running 2 SSDs off 1 CPU thread with 2 to 4 gig of RAM.
Yeah, I noticed
that wasn't a core, that was a CPU thread. At least that's what they're claiming, and that is incredibly efficient.
Achieving 71 microseconds the right latency, right?
Yeah.
I mean,
yeah.
Kernel bypass helps.
And they're doing it without context switching.
Right.
Yeah. And the way they were able to do this is because of their initial design of shared nothing architecture. So with shared nothing architecture, there is no coordination required. When the coordination is required, we tend to do context switch, bottlenecks also crop into picture.
Spin locks.
Yeah, spin locks, locking.
It's expensive.
Exactly. So once these things go out of the picture, then they can optimize for such use cases. So that design choice is very nice. Like we have always seen shared architecture is better or shared nothing architecture is better. I think both strategies work. It's how you are able to get it done.
I think the hardware also met their need, right? So you couldn't do what they were doing 15 years ago because the first of all, NVMe wasn't a thing, right? So
exactly.
NVMe enables all these new things, and so a lot of these companies that were not built on NVMe but retrofitted to NVMe, their existing code base, they weren't going to change what they were already doing. So of course they weren't going to be as efficient. So now you get the newer storage companies. But that's what I mean when I say what new thing are what's going to be new that's going to be met by hardware based on the new technologies that are being built. I mean, who knows? There's a lot of work on that. We were talking about the SNIA and DNA storage coming out. When that gets a little bit more mature, what's going to be built on that? Who the heck knows? I mean, I don't even know what it's going to be like. But not a lot of power required there, right? And I was going to say, Max brought up efficiency on power. I think there's a need right now that it's the ability to serve up storage and performance at a much lower power consumption rate, because although CPUs are cheap, they are more expensive. They're getting more expensive to run.
Yeah.
And everyone's got sustainability initiatives, both for the right reasons and for selfish reasons. So that's something I think I'd like to see the hardware vendors start to approach and say, okay, how do we get this performance? And StorePool is doing a great job, right? They are providing a performance level and a capacity level at a lower power consumption. But can the hardware companies deliver platforms that can help them do even better? I would love to see that.
So I think you brought up a really great point with the companies that are retrofitting stuff onto the new, faster stuff. So think about legacy hardware, legacy hard drive. SSD came out, and those guys all went, well, we're just going to take our existing code base and go, yeah, no, this is just faster. And then they did it again with NVMe.
Yeah.
Well, the companies that really succeeded were the ones that started from scratch and went, okay, yeah, this is really fast. How do we write to it really, really fast? As opposed to the guys that went, okay, well, this is the crap that we wrote. And I'm thinking, big, large company from Boston, or that got bought by Michael. So, I'm thinking they took their old code base for hard drive and went, hey, let's just focus this on SSD and now NVMe. And yeah, it's faster, but it sure as hell ain't fast, because they were expecting latency from the hard drive. So their code have to be perfect, because when you've got microsecond latency coming from the spinning media, who cares if your code's not perfect?
And then over time,
it matters.
Right.
Yeah, over time, then the code base improves, the approach improves. So instead of treating the new thing as a fake version of the old thing,
right?
Like an SSD is not a fake hard drive; it's a new thing. And then you start seeing people treating it in a new way, like with SolidFire, with Pure Storage is doing that now. Some of the next generation companies absolutely are doing it. They're treating SSD as a completely new animal. And that really helps.
And we'll see this again when we go with DNA-based storage or quantum storage or whatever the hell the next thing is going to be that's going to come out.
Well, I was going to say, one of the discussions I've been having elsewhere recently is there's, when you actually build new hardware, electronic design automation goes through a load of simulations to just test the hardware, see if it works, try to make it as efficient as possible, try to get it as space efficient as possible. None of the simulation ever happens on software. And you could improve software so much more if you actually started attempting to simulate the software operation and run a handful of different simulations, trying different things to figure out if it's better. And I don't think anybody ever thinks about this, because software doesn't cost anything to make where hardware does. But I think if you started actually attempting to simulate what you were doing in software, you could actually try a bunch of different things and be able to make it much, much more efficient.
Yeah, that's an interesting idea.
I think that's a great point. Databases are better at doing this. Foundation DB is a database which was first designed for simulation, and then they wrote the actual database code. But the problem is, with storage, it's not happening. We live with the age-old way of testing using automation test suites and injections and something of that sort. But that's a great, point. It requires a lot of effort, though, to write the simulation, and the fact that these companies they want to get the product out in a faster manner. They tend to work more on the features rather than testing it.
Yeah. So the other question is what we had just in the back channel. Will storage vendors in the future still run on x86 or maybe on some ARM, some RISC-V, some more power efficient things? And especially with RISC-V, I think this is an open architecture, so like open source. So more or less everybody could take just the architecture and build its own specialized piece of hardware for especially its storage RAID system or erasure coding system. Better to say.
Yeah, absolutely. And I'll I'll point out too that ARM is moving aggressively to add CXL to their processors, even ahead of Intel and AMD in terms of implementing CXL2, where Intel and AMD have not yet done that.
We've also seen some computational drive vendors incorporate ARM processors into their drives, and even RISC-V actually. So I mean, it's starting to show up in some storage applications, I'll call it, and it's the way of the future, right? I mean.
And the first RISC-V and chips are pretty power efficient too. Back to Max's point about efficiency, we're seeing some great power efficiency coming out of that architecture and out of ARM that we're not seeing in x86. Mainly, like Wolfgang's pointing out, because you could have a RISC-V storage processor that only has the instruction sets you need and doesn't have to waste time with the things you're never going to use.
Yeah.
But coming to the computational storage example, right? And because I was talking to those guys too, and it's not easy because you have to rewrite code. You can't just use existing code on it. You have to like completely rewrite your application to take advantage of it. But what I was concerned about from the power aspect, right? You now have computation on these drives that you didn't have on a standard drive. And so unless those drives are getting utilized all the time, that you're still powering those CPUs because it has to be on and ready to accept data to go and execute code. So what's the power profile of a computational storage array versus a regular NVMe array that StorePool or somebody like that can use and push the computation up? I'm not sure.
I think with enough sophistication, you can power down, cores and things of that nature.
They're not doing that now, though.
I know they're not doing that now, but you can see that sort of capability in the iPhone and things like that with low power cores, high power cores.
And for the point, they are doing that now. ARM and Intel specifically have low power cores that they can power on and off and move workloads between.
But not on the storage.
Implement that sophistication in the drive.
Right.
And some of the computational drive vendors are using things like containerized applications. So if your containers run on Kubernetes or Docker or something like that, you can potentially run them on the drive itself. So,
yeah, I would love to see some of those use cases right now. Anybody like using that?
Mostly, the transcoding and things like that are perfect use cases for computational storage because it's data to data and it's lots of it.
And the other way of saving power is now you don't have to move data. Normally, when you do compute on data, that has to be in the DRAM, host GRAM. So moving of data from the device to the host DRAM, then doing computation and then storing it back to the device is a costly operation in terms of power. But if it is on the drive, you can just do P2P using a P2P of the PCI bus, and then you can get away with not moving data. So that saves power. I think the real challenge with computational storage at this point in time is the cost. Like for our research, we got a drive of an 4 TB drive with Xilinx FPGA on it, and it costed somewhere around $20 to $100. So that's like a huge pain point in that sense.
Well, one of the things that I'll bring up too on that note of computational storage is one of the things that CXL is bringing is shared memory. And to your point, Rohan, the idea that you could access and not only shared memory, but shared access to storage in a coherent way so that you could actually have computational storage implemented as another CPU in the CXL fabric that is allowed to access the storage without having to move the storage and without it being the big, heavy, expensive host CPU. And that's not just something that's an idea, that's something that's being implemented in the protocol. And it's very exciting to think about what that means for a storage array when you have many-to-many access, shared access to memory and storage across a high-performance bus like that without having to move data. It's very smart.
I wonder what the applications, though, like historically when we've had infrastructure and developers have written applications that run in that infrastructure and they have a general idea what it is for consumption purposes, not detailed. As things have gotten better, faster, bigger, their applications just ran faster or better, they were able to store more data, great. CXL and computational storage changes what applications do and how they do it. It will force a change of how developers have to understand how their applications and different pieces. I'm just wondering how long is the adoption phase of that?
You have to provide a virtualization layer so that your computation can run on a host CPU or can run on the computational storage or can run in CXL shared memory, and all those things are options, and it's all managed through the virtualization.
Well, it's a virtualization. I guess it would have to be a virtualization optimization layer, because you'd have to like refactor code on the fly to take advantage of all the new things and new paradigms. I'm not saying it won't happen. It's not going to be easy. I think it's going to slow down adoption of this stuff.
But you can see a preview of what this is going to look like by looking at what NVIDIA is doing with their HPC
look at
cluster.
what VMware is doing with the
NVLink
DPUs
direct
and stuff like that, and Project Monterey and distributed solutions. I mean, they're moving ESXi to run on the DPU. I mean, it's a pretty impressive solution.
So maybe this would be something cool to do for a future storage field day. I'd like to see some of this new whiz-bang type of non-electronic, non-silicon based storage. Like Glenn, I think you talked about DNA based, or was it you, Denny, right? So like chemical based storage. Is there anybody that's actually doing that right now is kind of thinking?
If you go to the SNIA event, you'll find out.
There are a couple of companies that are doing DNA storage. The challenge is read and write speeds. It's not anywhere near where they need to be.
It's also $6 per gigabyte right now storage.
Yeah, and it's, but you could effectively store maybe a petabyte in the size of a test tube or something like that, or multiple petabytes. And
as long as it's not Elizabeth Holmes coming to preach to us about it, I'd like to hear more about it.
Lenovo has a
one drop of blood, and we've got your entire.
Thankfully, she's busy right now.
Yeah, she's
okay. Yeah.
Okay, we'll leave that go.
But let's think about let's wrap up. We've got to wrap up here in a minute. I want to give each of you a chance to jump in with sort of a final thought coming out of Storage Field Day 25. What was that we like to say? There's sort of a storage field day truism that every field day event has a theme, even though we don't actually intend there to be one. Every time we go to field day, we come away and say, wow, isn't it strange that all the companies talked about this thing? Because that was the theme of the event. Even though there is no explicit theme, we definitely don't set one. And we do that on purpose. We want it to be broad, but we come out with a theme. So what is the theme of Storage Field Day, and what does it tell you about the future of the industry? I'm going to go sort of at random here between the remote people and the local people.
Storage isn't going away no matter how or what we do. It's going to be here forever.
So I would say that the theme I got was block is not going anywhere, and it's all about making block faster.
I want to say storage certainly isn't dead, but companies are trying to be more transparent with the value prop and the value around the storage. And I'm glad to see it. I'm happy to see it continue to grow.
All my storage is infected, and I've got to get home and find out which ones.
At the very end, every piece of data is a block.
I love it.
Very true.
So this was more from the block perspective, this storage field day, but I think a lot of innovation is happening on the hardware side. Storage is definitely not going anywhere because a lot of data is getting generated. So yeah.
Well, everything we're doing is in service to the data. And so our customers need outcomes, and all these solutions are put together to just meet them. And us old storage folks have to figure out how to do it efficiently, how to do it reliably, and in high performance.
Local storage isn't going away, even though the cloud is getting all the attention. But you have to be aware of the ransomware attacks, because your data may not be uncorrupted, and you may not know it until it's too late.
Storage and data are growing. There's a handful of new services that come along, but overall, it's mostly the same old services that we need to maintain and protect our data and use our data that are there. When new demands arise, we will take care of them, but the old demands are still there.
I think the storage ecosystem is healthy. There's transition going on today. Cloud is a major aspect of what's forcing that transition, but the hardware technologies are starting to come online that are going to make significant changes to what storage does and how it looks. It's surprising to me that here 20 years later, 40 years later, we're still talking about lots of the same capabilities, but with different aspects, with different solutions. I mean, SRD is very interesting technology. The stuff that StorePool is doing with software-defined storage is pretty hot. The Cybersense stuff and what they're doing with ransomware detection is very interesting. This ecosystem surrounding data is never going to die.
I think that we like to talk a lot about innovation, but as you've seen, we had one of the presenters show a solution which is 20 plus years old, which is still very much relevant to solve the challenges of today. So at the end of the day, it's about things, how other solutions are architected. Also, we like to talk about the fact that some media types are dying, for example, tape. I know we didn't necessarily talk about tape in this field day, but there is still a lot of opportunities there to extract value out of that.
Amen.
Long-term storage.
Yep, absolutely. And I will say that we recently published some of the best of field day presentations, and one of the best of was a presentation on tape. Because to be honest with you, there is no better sustainability solution.
Mm-hmm.
There is no better data protection, loss prevention, ransomware protection, et cetera, solution than air gap tapes. Works really, really well, and they take no power. So